Warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Hello, my name is Rarasmaya, and I will be the moderator for today's session. We are welcoming all of the participants of the fourth week of Adjunct Professor lecture series about Industry 4.0. This event is held by the Department of Information Systems, Faculty of Intelligent Electrical and Informatics Technology, Institut Teknologi 10 November. I would like to welcome our honored guest, Professor Chou from NTUST. Professor, thank you very much for coming.
You're most welcome. Very happy to join.
Thank you. Then I would also like to welcome Dr. Mujahidin as the head of Information System Department. Pak Muja, selamat datang. Okay. Before we begin, I will show the meeting rules. First, please use your full name in the Zoom meeting, and then fill in the presence, which link will be shared in the Zoom chat later. And then, if you have any question, you can raise your hand or write it in the chat room. And then, certificate of attendance are available for participants who join the 6 classes. And then another certificate will be added for participants who pass the evaluation. And this is the fourth session, so you only need 2 more sessions to go. And then this is today's schedule. We will directly start the lecture session after this, about 1 hour. And then after that, we will enter the Q&A session. And then Mr. Indi will give a reminder about the mini project that were assigned last week. And then after that, we will have a closing about 20:05. Yeah, this Adjunct Professor program is a program from ITS that aims to activate an international academic atmosphere in the ITS environment. And then this program is also aims to activate the culture of international publication, increase the number of ITS international lecturers, and increase ITS reputation in the world. And for the Adjunct Professor program in the Department Information System, we invited Professor Shuo-Yan. He is the distinguished professor and director of Center for Internet of Things Innovation in NTUST. Yeah. And then his research interest is about Internet of Things innovation, industrial Internet of Things, big data analytics, artificial intelligence, smart city application, blockchain application, intelligent transportation system, entrepreneurship, decision theory, digital manufacturing, and computational geometry. Let me give a brief recap about last week's session. Last week, we talked about digital fusion, in which Professor Chou explained about the relation between IoT, AI, and blockchain. He clearly summarized that in digital fusion, IoT is used for gathering the data, while blockchain is used for securing the data, and AI is used to dissecting the data or to recognize the data pattern. And in this session, we will continue the topic and talk about Industry 4.0. What is the implication of IoT system and software role in the era of Industry 4.0? What is smart factory and digital manufacturing? All of that will be answered in this session. So let's not wait too long. Please welcome Professor Chou. The time is yours.
Thank you for the introduction again, Raras. And thank you for the summary. I think it's very precise on what I have covered last week. Again, just following what you just said, I just want to flip through those slides. And I think over the past, let me see. I need to flip. It's the right one, right? Okay. Yeah. After the previous 3 weeks, I feel that I could have provided you the full set of slides, but I don't need to cover all of them. So I feel a little bit guilty that last week we didn't have time to allow you to ask questions, and it was very rushed. So today I try to limit the number of slides that I use for presentation. At least I want to go through it quicker, and so that you have time to ask questions. And yes, indeed, what I talked about last time was about digital fusion. I use the 3 digital technology and show how we can combine them together and use them simultaneous, complementary to each other, so that we can develop different applications. A single technology by itself may not be sufficient to support the full needs of certain application, but combining them, 3 of them, as Rara just said, that one help us to get data from the physical world, so that we can utilize the information, the data and subsequent information to better manage the physical world, which is very important because we do live in the physical world. Doesn't matter how inclined or how much time we spend in the digital world, but our brick and mortar, we eat, we sleep, we do things still in the physical world. So being able to get the data from the physical world is very important, and being able to get the data all the time, everywhere, is very important. So IoT provides us such kind of infrastructure. However, in the digital world, we still have this superficial barrier, that is, we cannot present value. We cannot own value. Right? The value represents how well we can manage our lives. If you don't have any ownership, or your ownership depends on still other parties, other human beings, then it does present risk. No matter how small it is, in fact, it's quite big, but no matter how small it is, you do not have true ownership in the digital world. Right? The bank said that you don't have money, because it's not like in the physical world. In my pocket, I have cash. I can use the cash. Doesn't matter who said what. The money is in my possession. I can use it. But in the digital world, you can. You just can. There's no way that you send people a number and say that this is the money. You are still relying on the physical world. So that is also a gap. Right? How in the physical world, things are triggered by a lot of things are triggered, development triggered by cash flow. So without money flowing smoothly in the digital world, without a system which can preserve your ownership, allowing you to have a secure livelihood in the digital world, that becomes a problem. So blockchain will be able to serve that function. And a lot of data, again, a lot of data we got nowadays, because we have broadband, we have all kinds of storage. So we got a lot of data, but those data are just unstructured data that we cannot utilize. It's just consuming our storage space, not providing too much for us. But with the AI, turning these unstructured data into structured data, then more sensors, more complicated sensors can be utilized, so that we can extract useful data, and those data can be analyzed subsequently, so that we can utilize them for support decision. Okay, so these 3 technologies are very important. And as I said, the history never ceased to surprise us. That is, just when we are about to say, we are doing very good now, we should be able to sustain for a long time. There shouldn't be any surprise coming out soon. Then something happened. Blockchain was one thing. Right now is quantum computing. So there are things coming out still. So you still need to pay attention to the development, knowing what may come out, so that you can grasp the opportunity and participate in the development and obtain the opportunity. So so blockchain, and last time I sort of skipped it. This is our design that I was hoping to build up our blockchain system on campus, but of course I was not that successful. But even within the campus, we may be able to utilize blockchain to record things happen in the school, record the value created in the school, so that they can be sustainable. So that's also a possibility. And I also mentioned that the new World Wide Web still under development, which is trying to cope with all the kinds of problems that we are facing in the current digital system. So peer-to-peer, so that it will not be this winners take all situation, and spatial web, semantic web, smarter AI, extended capability, including IoT and so on. All of these may be included to Web 3.0. And I mentioned about Tim Berners-Lee's initiative on PAT, which allow us individual to have our ownership of our own data, okay, so that we can have a better web and a better society in the future. So it is still a lot of things that we need to tackle in the future. And here I say that seeing but not perceiving. We see the video or computer get the data, but doesn't know what is going on. But now we have AI which solve that problem. And I talk about AI, I talk about this digital fusion. Just very quick recap, because last time there wasn't any question. I'm not sure whether or not it's because I didn't explain things clearly, or I didn't have time left so that people couldn't ask questions. But again, digital fusion is about these three technology, okay? And I would still want to emphasize that AI, artificial intelligence, the intelligence is like human IQ, because artificial intelligence is trying to create an artificial human intelligence. So that intelligence is benchmarking human intelligence. But whenever we talk about smart, it seems to be, smart, intelligent, okay, it seems to be interchangeable. Our intelligence, if we say that intelligence is about AI, artificial intelligence. Smart, I will use a different characterization. I will say that it is just something street smart. It doesn't need to involve super intelligence. It's just smart. Like this person is street smart, meaning that this person deal with things very smoothly. Right? This person understand the context, having the right empathy, so dealing with the problems. Wow, this person is smart. This person is intelligent. These are two different kind of characterization. So AI is about intelligence, but a lot of so-called smart applications are just being smart. How can we be smart? I think all of you can try. If people ask you, can you come up with some smart solution? I think maybe I would say, if you examine the smart solution people came up with, I think I will optimistically say that maybe 99% of them involving getting data, getting right responses. Okay, making something unknown becoming known, so that you can respond correspondingly. Okay, so smart is just a data-driven process from my perspective. When we talk about smart city, it's about putting IoT, getting data to manage the city better, right? So that's getting data and utilizing the data to support all kinds of decisions. Similarly, when we talk about smart manufacturing, what is there that require smart, that need to be smart, right? If you think of it, it will be, if we have a factory without sensors, without connectivity, when you look at the factory, maybe in the morning before you start manufacturing products, everything, you know everything, every status. Once the production process start, at noon, if I ask you the status of the factory, I think chances are, I don't know. You will say, I don't know. I don't know which machine is broken. I don't know whether or not how much material we have consumed, whether or not we are ahead of time or we are behind. Is there any machine which is going to break? Do we have our inventory arriving? Material that we get out from the warehouse, where are they? How come I cannot find them? Chances are you don't know, because you just don't have data, and you cannot just see the physical world and suddenly you know everything. So you can imagine that when we talk about smart manufacturing, it's about being able to capture all the status, all the process digitally, and you have all the data. Then you say, well, once we have data, we can write program, we can write algorithm, we can analyze the data. If one machine break, I get the information, and I know the status of the manufacturing system. So I can quickly say, okay, let's do this, do that. Let's get everything back online and start working. And the better or the more data that we have, the better off we are. So we can utilize this data to respond correspondingly, right? So when I look at the so-called smart, I would say that it's about data-driven process. Okay, data-driven process. But when we talk about smart, definitely we don't want to think too much about technologies only. When you talk about smart cities, okay, so you have like robot cops, right, doing all the smart things, right, killing criminals or capturing criminals. Whenever you do something wrong, even minorly, you got caught. I don't think you will feel that the city is very smart. So although it depends on this data-driven process, I think the beginning of these smart solution should be user-centered, like solving the problem of humans, so that human can feel that the system is smart. Okay, it's not for the purpose of being efficient, effective, and creating or constraining all the people living within. So it has to be user-centric or user-centered. And it has to involve some technologies. Otherwise, it won't happen. Without technology supporting or enabling these services, these solutions cannot happen. And once you use this technology to automate certain process, of course, you need data. So it is a data-driven process. So when I I think I participate a lot of activities on like smart building, smart city, smart manufacturing, smart agriculture, all these things. Particularly for smart city, a lot of people will talk about many applications, and in the end, I think usually people will ask, "Can you give me a definition about a very succinct definition about what is smart city?" It seems that it's everything, and I still don't know what it is. So I try to give it a very vague definition. It is about data-driven that support the management of the city. And again, as I said earlier, it should be user-centered, right? Solving pain point of the citizens rather than just for the governance. Okay, so utilizing certain technologies, most likely digital technologies, and having this data-driven approach, everything will be based on the data. Why do you want to increase the width of the street? Why do you want to reduce the frequency of the bus service? Why do you want to buy more train or developing a specific MRT line to certain places? You require data, right? And some are long-term data, but some are short-term data, and some are instantaneous data. All of them need to be combined together, but it should be data-driven. And in the past, it was very difficult to get such data, but now we have technologies that allow us to acquire these data continuously in large quantity. Okay, so we have the ability to create a lot of smart solutions in our physical world. Smart city is for sure one. And another thing I want to remind people is when we talk about artificial intelligence, if we only think of using artificial intelligence to replace human, then we will have tremendous threat in the world. There will be job displacement for sure. Right? We say, oh, okay, this job, too many people. Let's use AI and get rid of all these people. And in the end, there will be somebody, some company, or some country which has the super AI, and they don't need anybody else because they can replicate as many AI as possible. Then the society there will be very few people super rich because they have super AI. The rest of them have no jobs. And it could happen. It could happen. To the extreme, it could happen. And so there are also people promoting the concept and say that human and AI should complement each other. And we shouldn't design AI with the intention to replace human. So for the time being, we can think of AI as not artificial intelligence, maybe augmented intelligence for human. Right? A lot of things that we cannot do better than AI, AI will do it for us. But we still need to keep those keywords. Not just for the purpose of surviving. I think also very important that because there was also a different argument that if human rely on AI for a long time, human will deteriorate. Human intelligence will deteriorate. Right? So we still need to think. We need to create. We need to find more things that AI cannot do, so that we can still improve. And hopefully, in the future, we can also develop more intelligence to augment human intelligence in the future. Chances are, my perspective, chances are AI will never be the same as human for many reasons. I think one of the most fundamental reason, I think, is AI can live forever. AI can live forever. A human, like everything is there, but life is not there. It's not there, and it's gone. Yeah, doesn't matter. And this is a very subtle difference, but it's true. So human have love, have hate, right? Have just imagine that if you have forever to live, right? You probably would not feel sad when you are departed with somebody that you like, you pursue, right? Because you have forever to try for another one. So I think machines have difficulty really feeling the kind of needs that humans have, because their life has no limits, and that present a very big difference. Biochemically, we can create them, but their lives, their digital life will continue, but our life will be limited. Okay, but again, I said earlier that up until now, that's how I feel, but I don't know. Maybe in the future, a human really brain can be preserved and somehow can still be enhanced, and all our bodies are robots. Now that I think of it, that could be possible. But anyway, I want to sort of emphasize that these are smart application that we are going to talk about. It doesn't have to have super intelligence. As long as we can use IoT collecting data, collecting right data, and maybe converting all those unstructured data into structured data, we can dissect the data. We can keep the integrity of data. We can dissect the data, and meaning that we can create more structured data, which allow more tool to analyze. Then we should be able to create a lot of smarter solutions. Smarter solution than what we have right now. Okay, so it doesn't have to have like super AI to become smart. And in smart city, as I also said, that city has all the sensing capability and understanding the pain point, understanding the problem. Then we should be able to utilize those kind of data, combining different kind of information technology, allowing these problem being solved, right? So yeah, I'm also quite interested in smart city solution as a city. There are many things that we can do. A lot of people are still doing this infrastructure development, like smart street lamp, trying to build up wireless communication, different kind of infrastructure. I think earlier I mentioned about something like LPWAN, or low power wide area network. Or right now we have 5G. 5G can allow broadband or massive devices within 1 square kilometer. 5G can allow over about 1 million devices connected online. And if we allow peer-to-peer communication, that's device-to-device communication with the station and with devices which can do device-to-device communication. You can have even more devices communicating to the help of 5G. So many different kinds of solution can be developed, but the infrastructure need to be there. Okay, the infrastructure being able to get the data and sense the data and acquire data everywhere and continuously, which is very important. So we talk about Industry 4.0, and usually people talk about Industry 4.0. I mean, they put pretty much everything in Industry 4.0. But what I argue about what is Industry 4.0 is from the perspective of industrial revolution. Okay, 4.0, you probably later we'll see. I will argue that Industry 4.0 is to emphasize that our manufacturing system, along with other like health 4.0, transportation 4.0, all kind of 4.0, is focusing more on personalized or mass-produced, mass-customized product rather than mass production. Just imagine that if we, in the digital world, forget about the physical world, just think of in the digital world, right? In the digital world, we can customize everything, right? You want to read certain news, they'll just feed you certain news. You don't have to have the same newspaper with the rest of millions of people. You can customize, they can customize your needs easily. But in the physical world, it's a lot more difficult. Okay, so Industry 4.0 is sort of the beginning of the new shift to meet the demand of the customer. Later on, I'll talk about it. And for manufacturing industry, it is more having higher digitalization. However, you feel that it's a little or a minimum. It is still better than, say, agricultural industry, construction industry, transportation industry, all the industry. Manufacturing systems are more ready to provide customized service, to have IoT creating value. And hopefully these kind of values can later be introduced to other industry. Earlier, I tried to emphasize that, not saying too much, but I said that I feel that healthcare right now is mass produced. I also mentioned that I feel that public transportation for sure is mass production transportation services, because the bus running on the street and I need to meet the requirement. If I do not meet the requirement, that's my problem. The bus will not customize its route or its timing for me. But we can make it more customized, more personalized. At least from my perspective, I feel that the bus came at the right time that I need it. As long as I know where the bus is, it's just that simple. And healthcare, right, and other things, I think sort of emphasize that. But where does Industry 4.0 came from? It is an initiative from Germany, and it was during their how should I say, the government's strategic planning for the manufacturing industry. They were asking whether or not their current, which was 2012, 9 years ago, 2012, they were asking whether or not their current manufacturing capability can cope with the societies 20 years from then. So which is maybe around 2032. They were asking whether or not their technology, manufacturing technology, can cope with the environment in 2032. The answer was no. But what will be the environment in 2032? So these are the issues: aging society, lack of skilled workforce, in fact, lack of workforce, urbanization, okay, clean urban production, environmental and overproduction pressure, increased product variability. People do not buy, or people want to have different product. They want to have variety. Shorter product life cycle. And there are also excess or idle physical capacity utilization. And I think this is a key point. By them, they think that the production or manufacturing system need to be able to do mass customized, low volume, high mixture products. So they need to have that kind of capability. Right now, the mainstream of the production system is mass production system. They produce a product for large quantity to obtain economy of scale, lower the price, meeting the demand of the customer, okay, and overproduce, and customer overconsume, creating a lot of environmental problem too. That's something we are, in one of our research, we are also addressing that problem. Like overproduced, overconsumed problem. So what would be needed to alleviate such challenges, right? Aging society, lack of skilled worker. For sure, we need to have something smarter to help us to produce. We cannot rely on just human, right? We increasing product variety, like shorter product life cycle, and so on. So we need to have a manufacturing system which can produce, including this mass customization, low volume, high mixture factory, meaning that we are in our factory, we need to be able to produce smaller batch, high variety products, right? And whether or not we can do that at the time that they were having this discussion, they feel that they do not have the capability. So if we position this kind of needs and we look at the industrial revolution of humankind in the last 150 years, I would say. If you remember the first industrial revolution, it was from human production to mechanical production. A human production, because we have steam engine having power, so it has a lot of power than human, right? A second industrial revolution was, on the one hand, we have electricity, so power can be transmitted to far away, and we have conveyor line, which allow us to have this division of labor so that workers can do very simple job. And at the end of the conveyor line, we have the products, right? That is electricity and division of labor, which help us to have this still predominant manufacturing strategy, that is mass production, producing a lot, trying to sell them all, and try to trigger people to buy the product, and so on. So that's a very overproduced, ever consumed strategy. And the third industrial revolution, I think is arguable, but I think the majority of the researcher or the society will acknowledge that automation is the third industrial revolution. That is introducing electronics and software into manufacturing, so that humans do not need to do everything, do every control. Computers can, not necessarily computer, they are computer-like system can automate the process. It's just like in the beginning of the computer system, we have this punch card. So automation in the beginning was like reading this punch card and knowing what to do. It's very constrained, like automate process. So it has very limited reach. The machine knows when something comes, the machine needs to do something and push it to the next stage. It has this capability, but it's not totally controlled. And a lot of things the machine don't care. The machine just care the processes. So that's the automation. That's of course automation become more complicated. But what would be the fourth industrial revolution, and how it is different from the third industrial revolution, which is automation already? Are we going to make automation more automated, or what are we going to do? What is there? What is not there that still need to be introduced to the manufacturing system, so that we can consider that we are having the fourth industrial revolution? What is there? I think that is a part. What is there to be added? Okay, so From Germany's perspective, they consider that if we can make this manufacturing environment transparent to begin with, right? We have all the information that we need. And since we have software, we can create a function. We can analyze the data. We can analyze the situation. We can respond automatically even because it's software. So they are envisioning this kind of environment. That is, for the current manufacturing system, they are mechanical, still mostly mechanical system. With, of course, with PLC, programmable logic controller, and with some system. But on the shop floor, it's very limited. It's definitely not information technology kind of IT. It is manufacturing kind of IT. It's very, very low level codes, like low level codes in contrast of our smartphone. Like we don't need to know low level codes. We just need to know app. We just call up the app. The app has some button. You press on the button, it will do things for you, rather than you need to change all the low-level codes. But in manufacturing system, low-level codes, like there's a line doing something, and the machine will do something. That's what they like, how they feel comfortable, and maybe that's what they needed in the past because they were doing mostly mass production. Why bother having these fancy IT and why bother having all other data? But if you want to produce a great variety of product, things are changing constantly, then how would you deal with them? It becomes too cumbersome to deal with them. So they feel that they need to bring information technology to the shop floor. They want to make the hardware become more like software, more like services, so that they can manage the manufacturing system. Okay. Of course, in the hardware part, we also need to have more mechanism, but those are only connecting issues. The main part of the machine, like if you drill hole, it will still be the same. But you can have a software which allow people to quickly alter the requirement, and the software will just drive the machine. Or also in the past, all the machines speak their own language. It do not communicate with each other very well. There's so many different kinds of protocols, and company hold on to their protocol so that they can profit from this proprietary capability. But because open source movement on software, now there are more and more open source concept for hardware and so on. So people are having different ideas of cooperating, and it is an opportunity. So again, from Germany's perspective, Industry 4.0 represents the fourth industrial revolution. Okay, what is there that, what isn't there that we need to add them to the system? And they said that it is Internet of Things. We need to have the infrastructure, need to know what is going on the shop floor, need to be able to control them timely, smartly, so that we can form a cyber-physical system. A physical system become a cyber system, cyber-physical system. So the physical system, just like the example that I had on vehicles, right? It used to be just people driving the car from one location to another location. Now it becomes pretty much everything that you need. Similarly, in the manufacturing system, it was just doing very simple. Although it could be very precise, it was just doing the same thing. And machines are doing the same thing. But now they want the machine to do different things. They need add more function to the machine. But in the past, the machine cannot deal with that. It's too complicated. Now we have software, and we add more hardware, allowing machine to have this ability to utilize these variety. Okay, so basically, Industry 4.0 is to make the system, production system, more flexible, more agile, so that the factory can cope with the needs of variety, smaller batch, high variety production. Maybe for most of you who have not really did any work in a factory, I can provide you some information, data for your information. Mass production nowadays, except for very few companies, like high fashion company, including products such as Apple's product, or some purse for ladies, or some fashion clothing, even though they are mass produced, they still have high margin. Otherwise, most of mass produced products are having very low margin. On the other hand, if you are able to customize products for customers with smaller quantity, if you are willing to do that, the profit margin can be many times of the profit margin that you get. Let's just say you make going back to this 2080 principle, maybe 80% of your products are mass produced, 20% is customized, and the profit that you got from the 20% of customized product can be as much or even more than the profit that you got from the 80% of mass-produced product. That is the situation. Unfortunately, in the past, it was very difficult. Like it is just imagine that the people managing the manufacturing floor need to be super experienced in order to cope with their production, because things do happen, bad things do happen. They need to be able to cope with them all the time, but they just don't have that access to all the information. So they are constantly fixing problem and nerve breaking, and although it's making money, but they don't want to do it. But now if we have sensor, we have data, we just can get them in real time, we can process them and respond automatically, then we can produce more with higher flexibility, high agility, and we can produce customized product for customer. Then for the time being, it's making more profit. Maybe 10 years from now, that's the only way. Well, will not be the only way, but for a lot of products, that is the only way that you can compete in the market. Because once other companies can produce customized products, and that's what the customer needs, and you won't be able to compete. Okay, so that is shaping gradually. Okay, not immediately. Oh, by the way, again, a lot of people, a lot of companies, a lot of countries are talking about, oh, they are ready for Industry 4.0, or a lot of people say, oh, we are not ready for Industry 4.0. It's still too far away from us. But even for Germany, at 2012, they said that Industry 4.0, it is a vision 20 years from then. And if that is realized, they feel that it will look like that. So even for Germany at that time, there wasn't any Industry 4.0 solution. It is just a vision for them. Okay, I just so happen to have the opportunity to be involved in a lot of European EU activities since very early on. So I participate in many meetings and listen to a lot of presentation and read a lot of presentation and document. That was basically what they said. It is a vision 20 years right now. And if we do achieve that level, this is what we think that it will look like. Okay, so not to worry that you are still far behind. I think as long as you know where the the goal is, I think there are many ways to lead to that destination. You don't have to follow people behind. You can take some shortcut, finding ways to reach there earlier. That's my my opinion. Oh, I did write an article for a Journal of International Affairs for Columbia University some time ago, trying to describe what Industry 4.0 will be. And mass customization versus personalization. I think mass customization is a big area. I think I wouldn't talk about it, but mass customization is using mass production technologies, pretty much mass production technologies, mass production time and cost to produce customized product. So how can it be so magical? The point will still be information technology. Like you need to know different needs of customer. You need to be able to sort of process the information. You need to send the information to manufacturing for. You need to allow this differentiation. So there are many ways to achieve this mass customization. It is a subject. In fact, I taught mass customization a little bit. It is an area. There are many strategies from design to manufacturing to logistic to the product, allowing customer to do their self configuration of the product. There are many concepts that can be introduced, but definitely is a beginning of this flexible mass customization or personalization. And it is just to complement the earlier statement that we started by having machine, but still we have very low volume, many variants. Right? This is the number of variants. And gradually we have fewer and fewer variants, and production quantity is getting more and more because of mass production. And after 1955, gradually we sort of curve back and we had mass customization being created. I think the most famous example of mass customization will be Dell Computer, their process. Before Dell Computer, you just imagine that home appliances, because we sort of view computers as like appliance to some extent, right? Do you go to the even nowadays, do you go to the appliance store and say, oh, I want to have TV. Oh, I don't want to have 4 buttons. I just want to have 3 buttons. I want to customize this, customize that. You cannot. You just cannot. But for Dell Computer at that time, because every component is very expensive, that's the beginning of the personal computer. So they have their system receiving orders and dealing with these differentiation, and workers can look at the screen and just put in a certain memory card or certain auxiliary components on the product. So workers are still doing this mass production process, but workers are creating customized product, and your order can be fulfilled within a week. The product will deliver to your door, right? So it's like personalized computer. It's not just personalized. It's not personal computer. It's personalized personal computer, right? And it's not much more expensive than standardized one. For sure, you won't buy standardized one. Well, you will if they happen to have the spec that you want. Otherwise, you just order from Dell. They give you personalized computer. So that's the beginning. And gradually, people think of making car, making clothes, making houses, making a lot of different things. There were a lot of examples. And more, we will not do total personalization, but we can still do mass customization. For athletic shoes, they will customize for you right? But at the elastic shoe, they probably won't be able to fit your feet very well, but they can maybe customize the shoelace somehow that can fit in your shoes and make it fit your leg much better. The other part, maybe they can stitch your names and change the color and so on. But for you, it feels like a total customization. Okay, but again, mass customization is an interesting area. There are a lot of things that you can do. If you think of designing a product that meets a greater variety of customers. But in the future, you will move towards that direction, more and more customization. A lot of things that in the past I would say a lot of things still do not need to be customized, but gradually I feel that the manufacturing industry are moving towards that direction. Oh, by the way, see, I have a mask, customized, like because now they are just this is like Michigan, okay, attending Michigan. So in Taiwan, I said, okay, let's find a shop that can customize the mask for us. So we probably order like I don't know how many, but I got 100 of them. It's not expensive, but they can do this, and it's still medical grade. It's not fake mask. I can still wear it outside and protect myself. Okay, so who would imagine that things that cheap can still be mass customized? Anyway, production technologies are better and better at the same time, and allowing information technology to fully utilize their capability, allowing us to have ability to create a more flexible, more agile manufacturing, producing a greater variety of products with minimum human help. But I would also argue that people are concerned about, I think I'm probably answering a question that people will ask. So Industry 4.0 seems to be taking all of our jobs. Like we don't have work anymore. But personally, I would argue that those kind of jobs are not really jobs suitable for human. Do you want to in the production line and do the same thing? Like 8 hours a day, like every day, and you say that this is human job. This is the job that human must have. Clearly, that's a machine job, right? And then if humans do not do those jobs, what do humans do in the future? I think there are still a lot of problems that we haven't solved. It's just that we don't have time to deal with them because nobody is helping us do this machine job. So we have to do that first. But once that job can be replaced by human, and then for sure, the industry, the society need to better utilize the human resources free up from the factory to do something that only human can do. Right? Like human need human as companion. Right? You have something set, you need a human to help you. I don't know, maybe for younger generation people, they can talk to their computer. I talk to Siri and Siri will respond and they feel satisfied. But I think in general, human need human to support. There are a lot of emotional empathy that human need to have. So I feel that again, jobs, just like AI, jobs will be displaced. But then people are also working very hard trying to create new jobs. Right? You don't want to do this the same, just moving your hand like for 8 hours a day, every day for many years. Right? That's my argument. Of course, in the manufacturing system, a lot of things need to be done. We need to be able to, since we are doing this flexible and agile system, many issues need to be addressed. Identification, how do we know this machine, this car body belong to who, and what need to be done? And so you can imagine the manufacturing environment is a conversational environment. Right? Machines are asking to products, and machines are asking product with machine. Human are asking machine. Machines are asking human, and they check the components, whether or not the component. A soldier will say, "Oh, how many pieces do we still have?" You can imagine that kind of environment, which is not that difficult nowadays. Okay, it is a communication environment. Not just they sense, they communicate. Okay, so sensing, data acquisition, wireless communication, and low energy. Okay, which is very important. So you can also have some energy harvesting technology. Bandwidth is an issue. Need to have a lot of interaction and control. Human need to control machine. Human need to control robots. Need to have more intelligence. Machine need to be able to talk to each other, interoperability. Lots of data that we have, we need to do analytics, and there will be for sure security and privacy issue. Okay, and this is something very old. That is, we need to connect the existing IT system with IT system we use from the computer, like changing the IT in the factory so that they can be more like the IT system that we have. So to put it simply, they have very low level IT, low level code, like assembly code kind of things. And we are doing this APP things. Right? There's a big gap. We are way up there. But between these two sides, there are many gaps. For one thing, manufacturing people do not trust anything in between. They feel that there are a lot of potential for hacking, for all kinds of problems, all kinds of bugs that still need to be dealt with. But also communication, like low level communication. Now we have high level communication. So we need to take all these machine data communication protocol and change them into our IT internet protocol so that we can gather these wireless information of the machine. That's usually we call them, or in Taiwan or a lot of places now we call this more like a smart box. We connect the traditional data, wired data connection to this box and send out these wireless information through say Wi-Fi, or earlier I said LP-WAN or whatever means. Okay, so that box convert this analog data to digital data that we can transmit and we can process. And we can even separate manufacturing hardware from the digital system. So this is a very typical information system for a company, right? I think for those of you who are in the information management area, for company, for enterprise, we have ERP system. Okay, on the shop floor, we have MES system, coordinating the activities in the manufacturing. And lower level, we have shop floor control, right? And on the machine, we have like PLC. Okay, and they need to communicate. And because different machines have different PLC, different communication protocol, and so on. So, but we don't need to know. So what we need to have is we can mask all these hardware and having a standard above, treating each hardware based on the kind of services they can provide. So we are treating all of them as services. And we can still allow this information system go all the way from the enterprise resource planning level all the way to the machine level. If everything becomes very smooth, you can imagine that things happen in the shop floor can also go through the channel going all the way back to ERP system. It doesn't have to, but at least it can go all the way to MES system, allowing MES system to know what happened and to redirect the HEV or acquire, change the command to the warehouse so that they can start delivering the material, all kind of things. If we have this low-level machine, which can also provide information at the service level, communicating with all these information systems, we can have, we sort of install or instill this capability, flexibility, and agility to the manufacturing system. Of course, this requires some effort, some coordination. They need to be interoperable. So that requires standard. Okay, there are different kinds of standard. We will quickly see that. And in Industry 4.0 system, it's not like traditional automation. Right? Earlier, remember I said the third industrial revolution talked about automation. The automation system, if you look at the standard called ISA, right? ISA 95, it is the information layers for automation. That is basically layer by layer, hierarchical. So few devices will communicate with the adjacent one. Seldom you will go above it. So the way that communicates layer by layer. And something happened, say machine breakdown, maybe control device will put up an alarm, but it may not transmit upward. Most of the things are going downwards. Very few things going upward because they cannot manage anyway. So for traditional automation system, it's hierarchical by layers, and the information is mostly from top to down. Very few from bottom up. So you can imagine if there's no information on bottom up, how can you cope with all the uncertainty, all the changes, right? But for Industry 4.0, basically everything talk to everything else, ideally, right? The machine breakdown, or the machine start the process, then we need to ask what happened. So a lot of information will be obtained and sent to different places. Or machine found out that it has consumed too much material. It needs more. The machine need to be able to sense that. Machine doesn't have to go the step. Machine can contact MES system. MES system can contact warehouse management system. Warehouse management can contact telling ERP that we need to consume more raw material, and warehouse management system will check whether or not they will be available HEV and whether or not they have a material and coordinate them, deliver to certain machine. It's not programmed. It's that things happen, and through communication, the system by itself can solve the problem, and all the necessary information can be transmitted to relevant parties in the system, can be updated. Okay, oh, I'm still too slow. But then maybe just give you another example. So with this kind of system, we can change the role of manufacturing. In the past, products were just, there's no identity. It's just raw material coming in. And when whatever they are being processed, in the end, they go out and then somebody bought it, it's their products. Let's just say, if we want to make a product which is unique for somebody, for example, somebody is very concerned about carbon emission. They want to have, maybe they want to get it as quickly as possible. That's one possibility. Maybe they want to have a green production, or they want to, their product, although from the appearance, they look the same, but they require a green production process. So the product, when it comes in the manufacturing environment, they know what they want already. They need to communicate with the environment, obtaining the right resources to process them. Okay, rather than I go to the bus stop and whichever bus comes, I just go there to take the bus. Instead, I said, I want to have electric bus. So then the information will tell me, oh, maybe not next 5 minutes, in 10 minutes, there's an electric bus. And then I go out and take the electric bus. Okay, and or there are many buses, choices of bus. They say, okay, that particular bus will be electric. You better take that one because you want to be responsible for the environment. So you take that bus. It's just like this product going to the production system. This product knows what it wants, and it will go into a production system, requesting resources, and all these requests by different products need to be coordinated in the production system, allowing them to meet the overall objective. It's changing the role of the product in the production system. And again, I would say that it is the same if you take this concept to other industry sectors. So traditionally, everything is mass produced. You go there, whatever happened, it happened. You just need to take it. But instead of having this mass produced service, now everybody go into a system. They request the
Okay, I think there is an internet connection problem with Professor Chou. I will invite the participant. If you want to ask any question, you can write it in the chat. And then after that, we will enter the Q&A session. So let us wait for Professor Chou. Okay. I think this is a very interesting topic from Professor Chou. So please ask many questions, as many as possible, because this is very, yeah. Okay, hello, Professor Chou. Your microphone is still in mute mode. Oh, okay. It's okay. It's yeah. Okay.
Oh, okay, sorry. Today, the Wi-Fi system in the school has some problems. So I switched to my phone. Okay, but I think I'm almost done. And there are a lot of other slides. I just want to emphasize the concept. There are a lot more slides in my PPT. I hope that you can read them. A lot of them are just example. Hopefully you can just get some ideas. I think a lot of them you can just by watching the slides, you know what is going on. I just want to emphasize Industry 4.0 from the background, so that you understand why it came out and how it is different from automation, or how it is different from say smart manufacturing. Smart manufacturing has a lot of different things, but smart manufacturing is not equal to Industry 4.0. Industry 4.0 started as an initiative and is focusing on the fourth industrial revolution, and is focusing on making more personalized or customized product in the future, so that the solution can cope with the market situation internally and externally around 2030. Okay, so I think I will stop here and allowing people, participants to ask questions, and I would, so go ahead.
Thank you,
Okay.
Professor Chou, for the interesting presentation. I already shared the material for today's session in the chat room, so the participants can, learn about other interesting application of Industry 4.0. And now we will enter the question and answer session. We already have 2 questions in the chat. I will read it.
Okay. Go ahead.
First question is from Mr. Rahman. What do you think about COVID-19 impact to the fourth industrial revolution? Is it slowing down it? Is it slowing it down? Because humans now have many restrictions, like they cannot work in factory or speeding it up, or maybe speeding it up because it forced humans to use more machine or technology. What do you think about the pandemic?
Yeah, I think it's a very, very relevant question. I think it's speeding it up. It's speeding it up because now you can probably feel that even if we want to use humans to work, like factory is just like school. Like factory is people are very easy to get infected, and they try to reduce the number of people working in the factory. And in the past, were still having a lot of doubts about just using technology and communicating remotely, and people having a lot of doubts and resistance, including myself. Like I didn't like to use conference call. Maybe I was a little lazy of learning all these functions. But now I'm quite familiar with the tools. So everybody is like this, and companies are trying to. They know that this will not be the end of the pandemic. This is the beginning of a series of pandemic, and this may be the norm of our lives in the future, in the worst case. And so, from my perspective, it will only speed up the process of utilizing technologies in manufacturing. That's my personal opinion. Pandemic make a lot of things happen faster than they were supposed to happen, particularly the utilization of digital technologies.
Yeah, thank you very much for the answer, Professor Chou. Yeah, I think personally this pandemic changed our lifestyle. So yeah.
Yes,
Everything
for sure.
can be done online now. Even
Right.
Okay, the
But
second question.
I think I will still try to visit Indonesia in the near future.
Yeah, please. We will be grateful if you come here.
Yeah.
Okay, the next question is from Miss Nurdwi Indah. According to Professor Chou, how is the readiness of developing countries in Southeast Asia to face Industry 4.0 by combining it with IoT? Do countries in Southeast Asia have enough potential to face Industry 4.0 as soon as possible?
So again, if we still follow the logic that I had, I think certain industry we do need to be able to deliver customized product. Okay, if a country which will be competing in that segment, then definitely that's something that you want to do. But for sure there will be different stages, so it will depends. Okay, but in terms of readiness, see, if we are thinking of Industry 4.0, the stage after automation, so the digitalization of the manufacturing system is the foundation. digitalization. So if your most of the machines are still traditional manual machine, then the gap will be bigger. But if a lot of machines have some minimum sensor, maybe it's analog ones and some digital ones, and integrating with the digital system, converting these analog data into digital data, or converting this machine-based IT information to the IT-based information, it will be a lot easier to create this new Industry 4.0 capability. So theoretically, we need to sort of go step by step. It doesn't. We couldn't reach the target directly. Okay, but however, having said that, I also want to reiterate what I said earlier. That is, if we know the goal, right? If we don't know the goal, we said, okay, we are not ready, so we can only sort of seeing what other people have done and try to do that step by step. But if we know the goal and we sort of follow the mainstream of the development, I don't think we need to follow behind other countries all the time. What will be the goal? If the goal in its abstract form is being able to produce mass-produced or customized products, and we need to have more digital capability. And on that part, personally, I feel that those are just acquired technology. It's something you can buy. You can buy the right machine, right? And one thing that need to be trained will be human resources. You need to have human resources utilizing those machines so that you will be able to turn them into something more digital or something more Industry 4.0 like. So it doesn't have to be behind others all the time. Just like in the past, if you sort of need to sort of go step by step. Although I said that we still need to go step by step, but not all the step. And if we know that the goal is there, and right now, technologies or machines is no longer like having competitive advantage. Those things are easier to get. You just need to take time to train people, to be able to do that. I think I had a lot of opportunity communicating with different school or different government official. I always say that I always like to use the example in Taiwan. Taiwan was an agricultural society for sure, as I was growing up. And then we see people traveling abroad to different countries to study. We see a lot of people returning Taiwan, a lot of people staying abroad, and we see changes within the country. But lots of people lots of family try very hard just to have their kids educated. And with a lot of people can contributing to the development initially. And as a society progress, and a lot of Taiwanese staying abroad, for various reasons, they return to Taiwan to seek their opportunity or to help out and sort of help Taiwan to grow again. And gradually, we also found our direction. So I think the most important part, which is also the role of the university, is truly need to cultivate a lot of human resources, high-level human resources. Machine can be bought, technology can be bought, but human resources, unless you also want to buy human resources from other countries, which will be more difficult. It's very difficult to manage people of different cultural, different background, but you need to be aware of what the society is heading to, what the industry are heading to. You need to cultivate the right human resources so that you can help the society to grow. Okay, but you don't need to do everything immediately. You can start from a focus area, meaning that you have many manufacturing industry. You need to identify one or a few which are more suitable for your development, like easier to succeed. In Taiwan, government every few years they have new plan, may not be good, but they will focus on certain industry, and the government resources will be in those industry, and people will compete, people will work on those topics, so that more human resources will be trained in those areas to support the development. Taiwan is even smaller, like you have probably close to 15 times of our population. I think if you have enough human resources, you can cover a lot bigger area than what we can do in Taiwan. But just that, I think higher education is still very, very important. So higher education. And China benefit from their higher education too. Doesn't matter how we feel about the economic situation and a lot of other things, but I have to say that they now have way too many universities, but then a lot of them were pushed to become very good universities so that they can train their people internally. So the bottom line will still be human resources, I feel. Larger amount of human resources, from high level to basic levels. You need to have all these human resources. Otherwise, we have many engineers and nobody know how to deal with the machine. So all of them are required. And of course, like for ITS or other top universities in Indonesia, and being the leaders of higher education, I think more importantly is you need to not only focus on very good work, you also need to broaden your understanding of the development in the world, which is really like this program, which is good. Even in pandemic, we still have an opportunity to exchange. Yeah, human resources is the most difficult one. Right now, US forced Taiwan to set up semiconductor manufacturing facility in the US. But still in Taiwan, a lot of people did not think that it will succeed because they just don't feel that US Americans can do the job. They just don't feel that they have the dedication to make things work. Really, they are just like in Taiwan, we criticize TSMC. We said TSMC has attracted all these top people to TSMC. They should have do a lot more better things for the society, but they give them higher salary and they go there and do very simple jobs. But because TSMC is making money, I think for the US, all those top companies are doing similar things. They attracted all these top people so they can make more money. For other places, they don't have right people to do things. So TSMC go to US, it will be, although in the short term, they may get some support from the US government, but in the long run, even the founder, Morris Chang, said that they won't be able to compete. We don't have, in the US, you just don't have that kind of people. So initially, they'll bring thousands of people to the US to produce the product, which is also a little bit ridiculous. Okay. So again, human resources is more important. Readiness, internal readiness, I think human resources will be more important.
Thank you very much, Professor. Yeah, that's a very a useful insight. Human resources is the basic of the country's development.
Yes, yes, it
Okay.
is.
Is there any question from the participant? Or maybe you can use, yeah, raise hand to ask Professor Chou directly. Okay. Okay, Professor Chou, I note some interesting topic in your presentation.
Hmm.
The first is that you think that the age limitation of human is an advantage compared with AI. Why do you
Uh,
think so? Because yeah, actually you already explained it, but yeah, it's very interesting, I think, because people usually see that limitation as a disadvantages, not advantages.
right, right, right. Uh, I meant that uh, that's the difference. Uh, like AI, a human doesn't know what is our conscious. How should we program conscious into AI?
Oh,
And we say something like human has this free mind, right? Uncertainty. Right? If you ask me, do I like coffee today? I may say I like it. Tomorrow I say, somehow I don't feel like I like coffee today. Right? Machine doesn't do that. And we have a lot of things that like if we want to write a point, point, um, although we say that now machine can do that, but it's basically imitate what human does. It doesn't really have this emotion. It can do this very mechanical, maybe, and it looks like real, and but it doesn't really have that emotion. It doesn't really have it, right? It doesn't have that kind of empathy on human. Uh, and it's just yeah, it's just that we don't know what it is, and we don't know how to program them. um, there was a, I think maybe I can also tell you, because I was involved for a short time on the IEEE standard on ethics in AI and robotics. They want to establish the ethic for AI. For example, for sure, AI shouldn't harm human. So we need to have this written in AI ethics, so that when AI will not get back and trying to kill the master and kill all the human. Right? So that need to be there so that we can sleep it well, because we know that AI will not betray us. Something like that. So ethics in AI and robotics, it is a very difficult issue. Um, there was an example I think is very, very interesting. That is a car driving along the way, and there was a few kids on the street. Suddenly jump onto the street. So the car has only two choice or two choice. One is just run over the kids. They shouldn't jump on the street. Secondly is turn and maybe fell off the bridge to save the kids. Right. So if you say that a good ethic is you shouldn't run over the kids, right? If you have made a car, you tell people that, oh, my car has good ethic. So when they see kids on the street, they will not run over them. They will jump off the bridge. Do you think that people will buy that car?
Yeah, yeah.
So, so that's also something quite difficult. Right? You tell the AI to do all the right thing, but then you are sort of scared of them, thinking that they may do something indirectly harm you. So it's just quite difficult to do. But as I said, human enjoy a lot of things that AI may not enjoy. If you watch movies, I think they have good characterization. They don't really have emotion. They can act like they have emotion, but they really do not have emotion. They don't have the true benefit of the emotion. Right? Treasure something, love something, right? Enjoy something. They just don't have that. Right? Just something like if you eat caviar every day, then you wouldn't enjoy caviar anymore. That's also what people said. But yeah, I think limitation also provide a lot of motivation for humans to live their lives better, right? To do right thing, because yeah, within the limited scope of their life or their capability, they feel something worthwhile. It does, as you put it, it is a limitation, but it does bring lots of goods, human too.
Okay, thank you very much, Professor Chou. Very interesting discussion, I think, especially about the ethics, because my research interest is about computer vision in medical image. So yeah,
Mm,
ethics is very, it's a very restrict, yeah, it in there, such
right.
as yeah, when we make a program that detects abnormalities, and then if the program make a wrong decision, we will be yeah yeah
Exactly. When the
yes
when the autonomous car ran over a pedestrian, is it the fault of the car, the fault of the manufacturer, or the fault of the people sitting in the car? Right, very similar to your issue. Humans may accept mistakes made by humans, but
yes
humans may not be able to accept mistakes made by machines. That is also the
yeah.
problem right now. Mm.
Okay, thank you, Professor Show. Uh, if there is no other question, I will make a simple summary about today's topic. Yeah, the first is yeah, Industry 4.0 is about industrial internet, and it includes cyber physical system, IoT, and Internet of Service. And Industry 4.0 is a step for the beginning of personalized product. And it uh, it can be possible because now we have the ability to gather a large amount of data continuously. And all of the smart activities that were developed right now, it should be data-driven process, and it should be user-centered. Yeah,
Okay, thank you.
yeah.
Very good
Thank you
summary.
very much. Maybe I will ask Mr. Indi to do a reminder regarding the mini project last week.
Hello.
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 Yeah,
Yeah.
okay.
Can you
Yeah.
hear me?
Yes.
Okay. Okay. Thank you very much. Good afternoon. I will explain a little bit about our mini project briefing. Actually, I just put the briefing materials in the chat. There is a link to Google Drive to show the mini project briefing. So maybe I can share my screen too. Let me try. So, okay. Can you see my screen?
Yeah. Yes, Mr. Indi.
Okay. Okay, this is for the mini project. Mini project topic of the project is IoT enhance or enable service. Service might include healthcare service, logistic service, transportation, factory, enterprise, and cities, and etc. So for example, that now we have like a COVID vaccination. So maybe you have some interest idea how to solve distribution of the vaccine using the IoT technology. For example, like we need to organize the cold storage and the transportation of the using cold storage to distribute the vaccine. And this mini project should be close to the market and practice as possible. Yeah, so maybe it's yeah, just like my example, it's more practical and maybe it's from the real problem or from the real cases. Okay, for the requirements, mini project report need to include synopsis or the background of the topic, case description, solution, and analysis. Then mini project report can be the PPT files, around 10 to 15 slides with necessary supplementary materials. It is encouraged to use more dynamic and lively format. You also can include like the video or other like media format in your slide. So you also mini project should not be just a presentation on an academic paper or report. It should be an investigation of practical issue. The project outcome should involve discussion and analysis based on concept and tool learned in the class or from the all the materials that professor already explained in the course. Mini project will be done in self-organized group, each consisting up to 5 students. Just remember, up to 5 students. Report should be submitted no later than July 4th at 11:59 p.m. West Indonesia time. And this is for the link for submission. If you have any problem to access this link, maybe you can contact me. And also please put your team's members information. For example, full name, student ID, department, faculty, and university in one slide, maybe after the title slide. If you have any question, please contact me, Indi, by email dewabarata@gmail.com. So if you want to talk using WhatsApp, we can give you my information, but please contact by email first. Okay. And this is some assessment criteria for the report that for the first one is organization. It's 10% from the score, total score, professionalism, problem description, solution description, and you need to put discussion like the analysis or maybe the critical challenge faced in implementing the solution. Okay, maybe that's all from the mini project briefing. So I already put in the chat the link to access this file so you can check it, and if you have problem you can contact me. Okay, thank you from me, Miss Raras.
Yeah, thank you very much, Mr. Indi. Yeah, we will move your Google Drive content to our Google Drive.
Okay,
It
yes,
contains
please.
the materials, which is in intip.in Adjunct Prof Materials 2021. Okay, let me remind all of the participants that the certificate of completion will be given after you finish the mini project. And you still have about 2 weeks to complete it. And now we are nearing the end of our session. Before we end this session, let's take a photo. Please turn on your video and I will take some screenshot. Okay, thank you. I will start taking screenshot. It's for the first slide. And then the second slide. And Okay, thank you very much for all the participants. Thank you very much also for Professor Chou. And thank you for Mr. Mujahidin and Ms. Erma Suryani. And also Mr. Indi. Sorry.
Thank you very much, Professor Chou. Yeah. Sorry, I just finished my previous meeting.
Oh, no problem, no problem. Good to see you. Yeah, I saw
Yeah.
you just.
Thank you, sir. Yeah. And how
So
about the next lecture? Is it on Thursday? Thursday, right?
Thursday, we'll be going back to a Thursday.
Okay. Thank you very much, sir. Yeah.
The next two lectures will be on Thursday.
Okay. Thank you very much, sir. Yeah.
You're welcome. You're welcome.
Yeah.
Let me remind all of the participants that the next Adjunct Professor lecture series will be held on Thursday on 24th June. And it will talk about smart manufacturing. So don't forget to attend. Yeah.
No.
Okay, with this fourth session of Adjunct Professor lecture series is finished. Thank you very much for your attendance. See you next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bu Raras. Yeah, thank you very much, Professor Chou, Pak Muja, Mas Indi, Pak Sony.
Thank you,
Yeah.
Bu.
Thank you.
Thank you.
Okay, bye-bye, sir.
Pak
Yeah.
Muja, Mbak
Bye.
Raras. Mas Sony tidak berjumpa. Mbak Raras pakai mukena itu ya.